Okay, so our presentation is on immunofluorescence tests, otherwise known as immunofluorescence assays, and I work with Narly, Natalia, and Nicole.
So immunofluorescent testing is making the use of antibodies to which fluorescent dye molecules are bound at the tail ends of antibodies. So this is just a picture at the bottom right here explaining it. And if you guys want to take a look at that for a few seconds, I'll leave it up. Okay. So the testing actually was invented by Albert Kuhns, and it was created in 1940 in the United States. And this is just a picture of him.
So the key science principles in immunofluorescence testing. So basically cells infected with a virus are immobilized by chemical fixation, meaning that they're put in place in a samples and so that they aren't destroyed by enzymes or anything like that or autolysis. And then the sample is incubated, during which antibodies bind to the antigen. So the antibodies will bind to the receptors on the virus, and then the sample is washed to get rid of the unbounded antibodies, so the antibodies that aren't specific to that virus. Then an anti-species antibody is tagged with a fluorescent marker, and that is added to the sample. And then this binds to the antibodies present in the sample that has bound to the antigen. And as you can see in the picture below, you have the primary antibody that binds to the virus, and then it's washed. And then you have the second antibody that's tagged with the fluorescent marker bind to that component. And then you have that can show the UV light. So after the second antibody is bounded to the virus and the primary antibody, it's washed one more time before it's ready to be examined using ultraviolet illumination. So when you are looking at it, the fluorescent marker glows with a bright green fluorescence, and this indicates the presence of specific antibodies bound to the antigen. And the pattern of fluorescence observed confirms the specificity of the reaction. And this test can detect antibodies, antigens, and complement at their locations within cells or tissues.
So this is just a little graph, like picture table that we found, because there's two types of immunofluorescent, which is the direct versus the indirect. And just to kind of differentiate them by their definition, direct means that it's a type of immunofluorescence in which fluorophore directly conjugate with the primary antibody, versus indirect, which is the second type of immunofluorescence in which fluorophore conjugated with the secondary antibody. And then the direct uses one antibody versus indirect, which uses two. And direct is just like uses less time than indirect. And that's about it.
So just to add on to that, so from what I explained previously, instead of there being a second antibody binding to the first antibody and the virus, there would just be one antibody with the fluorescent marker already tagged.
All right, so where and why was it used the first time? Like Natalia said, immunofluorescence was first reported by Dr. Kuhns in the USA. So the idea of making antibodies visible came to Kuhns and his colleagues to visualize group A, hemolytic streptococci, and the Aschoff nodules that characterize rheumatic fever.
Is it used at present, and how is it used currently? So immunofluorescences say the market was valued at $1.48 billion in 2018 and is projected to reach $2.27 billion by 2026. So it's growing at a compound annual growth rate of 5.47% from 2019 to 2026. So it is still being used, and it's going to continue being used. And recently, it was used with microfluid technology by scientists at Sekhanov University to develop a device able to isolate cancer cells from the urine of patients with prostate cancer. So basically, they developed a spiral microfluidic chip capable of isolating PCA cells from the urine of PCA patients or prostate cancer patients. And they used direct immunofluorescence assay, and the primary antibody they used was glypican 1.
So the companies that make these tests, there were a few that I was able to find, but these are kind of like the two most common ones. One is Multiomics, which is also the name of the type of test that they use for this, because the name of the actual company is Neogenomics. It is located all over the United States. Some of the like most common areas are like California, Florida, and Texas. And then for the value, one that I was able to find online was 25.97. And then the other company was BioBest. So they have been running since 1995, and their location is in the UK.
So currently, with the number of cases of COVID-19 rising, they have been able to use immunofluorescence tests or immunofluorescence assays to test for COVID. So the test immunofluorescence assays uses a label that is conjugated to the antiviral antibody. And then scientists are able to look at the amount of fluorescence that is seen under UV light, which allows the scientists to see the viral antigen and be able to identify which virus it is, what kind of strain it is. And in that picture, you can see where the arrows are pointing are the viral antibodies that are being seen.
So these are just our references that we were able to find and use.